Let's take a look at these two sketches here. So it says, what's the difference between them? I've constructed them in such a way that we can see that they are perpendicular to each other. See that? Okay, so they're both perpendicular. But what do you notice is happening to each of the segments? So look at segment AC, look at segment DF. What's the difference between them? Well, you should notice here that E is the midpoint of DF, where B is not the midpoint of AC. So watch what happens. I can take my point, which is on this perpendicular line, and I'm going to move it, right? I can move it, and I see that B is definitely not the midpoint. It's between A and C, but it's not necessarily at the midpoint. Where here, I try to move my point, and all it's doing is moving up and down my perpendicular line. Okay, this point is staying on this perpendicular line. This line here is what we call the perpendicular bisector. Okay, because now look, if I move here, notice my values, right? They're staying congruent. So my two segments are staying congruent. E is staying as the midpoint. So this brings us to what we call a perpendicular bisector. So copy this down in your notes. A perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. And we can see in this sketch here, it's exactly what I was just showing you in Sketchpad, that P is the midpoint. It is perpendicular to segment AB. So this line, CP, is perpendicular to segment AB, as well as bisecting it. So that's why we call it a perpendicular bisector. If we come back to our Sketchpad, I still have my perpendicular bisector that we have here. Notice this point, okay? Let's name this point. It'll be called point G, okay? Now, what can we say about point G? If I want to measure the distance from G to each of the endpoints of my segment, so watch what happens. I'm going to click on my 2 points. I'm going to go and measure their distance. Okay? The distance from G to D is 6.17, and let's look here. From G to F, measure distance. Oh, look at that, 6.17. G is going to stay equidistant from those endpoints of my segment as long as it's staying on the perpendicular bisector. So as I'm moving G, notice my values are staying equal. Okay? Now we could actually draw in a segment here and here. Let's actually make them dotted so you realize it's not necessarily a segment, but rather, let's change the display. A segment, but rather a distance, right? So that means that the length of GD and the length of GF are equal. So if in fact these were to be segments, the segments would be congruent. This point, which is on the perpendicular bisector, is equidistant from the endpoints of the segment. And what I just showed you is what we call the perpendicular bisector theorem. And that states that in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. It's exactly what I showed you in Sketchpad. Write this down.